In this video we are going to talk about the angular displacement. If I have an object just like this wheel at this position, so this position is called the initial position, and let's take the center that represents a point at the center that represents the whole object. So x sub I or xi represents the initial position. When I move this wheel from its initial position, which is called the final position, xf, the displacement that takes place can be measured by measuring the distance from xi to xf and determine the direction. But first, to measure this, we need a coordinate system. This coordinate system may be the ruler. In this coordinate system, we know where is the 0 point, which is here, and then xi related to this 0 point is 2 centimeters and xf is 14 centimeters. In this case, we can find the displacement by substituting these numbers in this equation. Delta x, which is the linear displacement, equals x final minus x initial. In this example, x final is 14 centimeters and x initial is 2 centimeters, so delta x equals 14 minus 2 equals 12 centimeters. In SI system, measuring unit of the length is meters, not centimeters. So we need to convert it into meters by dividing by 100, so it's going to be 0.12 meters. This is the linear displacement. What's meant by the angular displacement? The angular displacement is the angle made by the rotating object. Okay, so let's go back to our wheel. This is the wheel. When I rotate it like this, there is no translational motion. It doesn't change its position. It rotates. Rotation is a motion, okay, but it's not translational motion, it's not linear motion, it's rotational motion. The object doesn't change its position, but it rotates. As it rotates, we need to take a point and determine the angle made by this point, this angle. So we need to find or to make a coordinate system and find the 0 point and then measure the angle from this 0 point. So let's take the center of rotation, or the axis of rotation is our origin point. For the coordinate system, I'm going to draw these two lines. They are degrees, like this. So this is the 0 point from where we measure the angle. If the object is rotating counterclockwise, or this point is rotating counterclockwise, so it's a positive angle. If it's rotating in clockwise, is going to be negative. This is 0 degree, and one complete rotation makes 360 degrees. So a half rotation is 180, a quarter is 90, and 3/4 is 270, and so on. Our point is here, which is approximately 30 degrees. So this is the initial position, but in this case we are not going to talk about the position, we are talking about angles because it's an angular displacement. So the initial angle equals 30 degrees, and then when I move it to this point, it makes a different angle. So this is 30 degrees, this angle is 30 degrees, which is the initial angle, and the final angle is 60 degrees from this point. Okay, in this case, our angular displacement delta theta equals theta final minus theta initial. Theta final minus theta initial, which is 60 degrees minus 30 degrees equals 30 degrees. In this case, this is delta theta, this angle, this is small angle from here to here, delta theta equals 30 degrees. Okay, from the initial angle to the final angle. But we have a problem that the SI unit for the angle is rad, which is radians, not degrees. But it's not a big problem, because we know that one complete rotation in radians equals 2 pi, and by the way, pi equals 22/7 or 3.14. So one complete cycle is 2 pi. So half a cycle or half a rotation is pi in rad. So a quarter will be pi over 2. 3/4 is 3 pi over 2. So what about 30 degrees, the initial position? What is it? This is pi, and we have 30, 60, another 30 is going to be 120, another 30 is going to be 150. So we can divide this pi on one sector, two sectors or angles, 3, 4, 5, 6. Okay, so 30 degrees is 1/6 of pi. 60 degrees is 2 pi over 6, or pi over 3, whatever it is. In this case, our delta theta, which is theta final minus theta initial, will be 2 pi over 6 minus pi, 1 pi over 6. This equals pi over 6 in rad. So this is our angular displacement, which is 30 degrees. So we know that pi over 6 equals 30 degrees. Which is larger, 1 degree or 1 rad? And explain. We know that 360 degrees with 2 pi, 180 degrees, 1 pi. 1 rad equals how many degrees? So x in degrees divided by 180 equals 1 rad divided by pi. Cross multiplication, x equals 180 times 1 rad divided by pi rad. This will be 57.3 degrees. 1 rad equals 57.3 degrees. 1 rad larger than 1 degree. Okay, if this wheel makes 1.5 rotations, it rotates 1 rotation and a half. We need to calculate the linear displacement done by this kind of rotation. The equation is delta x equals r theta. In this case, let's say that r equals 30 centimeters or 0.3 meters. So delta x equals 0.3 times 1.5 times, you know that 1 rotation equals 2 pi. So this is going to be 2.8 meters. In this video, we talked about displacement, which is delta theta. Delta theta equals theta final minus theta initial in radian, convert between degrees and radian. And linear displacement of a rotating wheel, which is delta x equals r times delta theta in meters.